2.6 deals with linear inequalities, and this is a very big review of last year. So it's not, I don't expect you to struggle with this much. When we graph inequalities, we said the most important information is your sign. If it's less than or greater than, without that little line, we're doing a dotted line. If it's an equal also, it's a continuous line. So that's the main thing you want to remember. Dotted line, continuous line, okay? Let's go ahead and try and graph them. Y is less than -2. Well, first of all, where is y -2? I already should know by now this is a horizontal line. My y is -2 right here. It's the line that goes there. It does not have an equal. It's a dotted line. And every time you do less than, you shade underneath. We said this. Every time you have to do a less than, you literally shade underneath. So here we go. This is where all the numbers are less than -2. X is less than or equal to 1. It starts with X, that makes it a vertical line. X is 1 here. It's less than or equal to, so it's a continuous line, first of all. Don't forget to put the line. And again, we're looking at numbers less than 1. They were going to be at the left. How do I know this? Well, 0 is here, and that's less than 1. This is my numbers are less than 1. Let's move on to y is less than 2x. This is a y equals mx plus b line. I can put a 0 there and go, okay, 0 is my y-intercept. My slope is 2 over 1. 1, 2, 1. I have the 2 points. I can draw my line. This is less than, so it's a dotted line. And again, less than, we shade underneath the line. Our last stop is here. This is a trickier one, so we work it differently. This is a standard operation, so I can make, well, x is 0. That means -5y has to equal 10, or y will have to equal -2, right? Oh, 2, sorry, no, -2. Y equals 2. So I have my first dot. Y equals 2. Now if I make my y 0, and this is what we did last week, right? This is the standard form. We make x 0, get the y, makes the y 0. I end up with 2x's equals 10, which means x equals 5, right? X is 1, 2, 3, 4, 5. It's a less than or equal to line, so it's a continuous line. And the key would be now, where do we shade? And if we start thinking this is greater than and we shade on the top, this will be tricky because this is not in the y equals mx plus b form. This is a standard form. So we want to guess. We want to know, okay, what if I'm picking the point 0, 0? If I plug it in there, would that value be greater than, I was right, guys. I graphed it wrong. Y was -2. I'm looking at this going, this is not right. -5, 10 divided by -2. That's what I did wrong. Here we go. There's my line now. Here we go. My line goes like this, and it's not dotted, it's continuous. Never mind. Now we're back in business. Again, I want to know where to shade. And normally, because it's greater than or equal to, we would do it on top of it. But that might be tricky. Let's pick a point. Let's say I'm going to pick the point 0, 0 and plug it in. 2 times 0, 0 minus 5 times 0, 0 will give me 0. Is 0 greater or equal to 10? No, which means you can't shade on the top. You have to shade on the bottom. The other way to do this would have been to go from here to -5y greater or equal to -2x plus 10. We would move the thing on the other side. Divide by that -5, which would have switched my sign. When we divide by a negative number, we switch the sign. It would have been less than, so it's underneath it. But really, when you have something in the standard form, all you have to do is pick a very easy point and see if it checks or not. If you just pick 0, 0, you'll figure out that 0 is not greater than or equal to 10, so I can't shade on the top. I have to shade on the bottom. Okay? There's only 2 options. And this is about how we graph different inequalities, right? We're going to do the word problem on page 110 as soon as I erase this. And then we are done with 2.6. And this has to do with all kind of verbal modal stuff. We're talking about having people that live both in the United States and Mexico. We want to talk on the phone. We basically have 2 options. We either call people in the US or call people in Mexico, and they're telling you have a US rate. You're going to times that by how many minutes you're going to talk in the US plus the Mexico rate times the minutes you talk to Mexico. And all this has to be less than or equal to the value of your phone card. And the value of your phone card is, well, we're going to write this value, phone card. Let's go ahead and replace everything that you know. What is the rate in the US? 16 cents. 0.16x plus what is the rate from Mexico? 44 cents. 0.44y has to be less than or equal to 50, right? They want us to go ahead and graph this. The one way to do this would be to just use the standard form and go and do the divisions and graph it that way. But that would give you crazy numbers. So the best way we can do this is to go ahead and I'm trying to think if I want to, we're just going to go ahead and go 0.44y equals negative 0.16x. No, not equals, less than or equal to, plus 50. And then we're going to divide by 0.44, which means y is less than or equal to, let's go ahead and do that, negative 0.16 divided by 0.44. It gives me negative 0.36x plus 50 divided by 0.44. 113.64. And we can graph this using our calculator, right? Before we do this, the reason I'm doing this is to help you remember. We can't do this with our plot on. So we're going to have to go second Y, go ahead and hit enter, turn my plot off, hit enter to make sure it's off, second quit. And now I can go ahead and go to Y equal, clear whatever it's in there, and put that equation in. Negative 0.36x plus 113.64. This is what you should have there. If you didn't remember, x is right there, right? And now I'm going to go ahead and do, can I do that, I wonder? Zoom. There is a zoom fit, but I don't know if it always works or not. Mine did not work. So I'm going to go ahead and just do a regular Zoom 6 and graph it for a second. Once my calculator finished doing their stuff. Okay, Zoom 6. And it's starting to graph and we don't see anything, right? And that's where we said we're going to go to window and mess with our windows. This is a real life problem. So my X minimum and my Y minimum are going to both be 0. My X maximum, I'm assuming we're going to speak as many minutes as we can. I'm going to make mine 400. My Y minimum is 0. My Y maximum, I know what it should be. It should be 50, right, normally. But I'm going to make it 100 just to make sure. This is where I am. This is a real life problem. And now I'm going to hit graph. There's my line. And believe it or not, my Y is not even enough yet. So I'm going to go back to window and I'll make my Y maximum, I don't even know. You make my Y maximum 200. And then I'm going to hit graph. There it is. We now have a graph, right? And I can go ahead and graph it. We did this in class a lot. And obviously sometimes I forget stuff. But this is our graph. And it's asking us, it says, discuss 3 possible solutions in the context of a real life solution. You can pick any number. Basically, you would go, well, what if X is 30? What would be my Y? What if X is 100? What would be my Y? What if X is 200? What would be my Y? And that's how kind of you're going to work it out. You give different values to X and you pull your Y's out. Your answer will differ like crazy in here. And so that's about all there is to it. You will use your calculator to draw it and then give solutions to get it done. Happy homework on 2.6.